Here I have the integral of cosine 3x plus cosecant squared 3x dx. Since they're added, we can look at each one individually. So the antiderivative of cosine of 3x. Well, I'm going to start by finding the antiderivative of cosine is sine. So I'm going to have sine of 3x. But here, what we don't want to forget in the front is going to be the reciprocal of the number 3. So 1/3 is going to be out in front of this sine function. And so remember that we want to think about taking the derivative of this and making sure we get back to this piece of our original integrand. Well, the derivative of sine of 3x would be cosine of 3x times 3. The derivative of the inside would be 3. And that's why I need this 1/3 in front to cancel out that 3 that would come out from the chain rule. So that essentially gives us a little bit of a shortcut, that when the inside is linear, then what's going to come out in the front is 1 over the slope. So after I take the general antiderivative, so the antiderivative of cosine was sine, and then of 3x, 1 over the slope is going to come out in front. And something similar is going to happen here. So cosecant squared of 3x. So the antiderivative of cosecant squared of 3x is going to be cotangent with a negative in the front. So negative cotangent of 3x times 1/3. So again, that inside 3x is linear. What's going to come out in front is 1/3. And so we can check the derivative of cotangent 3x would be negative cosecant squared 3x. So that's why I needed this extra negative, because this is a plus here, positive. And then times the derivative of the inside 3. And so therefore I need that 1/3 in the front to cancel out that 3. And then plus c. Here I have the integral of 1 all over the quantity 25x squared plus 9 dx. Let's take a moment to recall that the integral of 1 over x squared plus a squared dx is 1 over a arctangent of x over a plus c. So that's not exactly what I have, but I'm going to rewrite my integrand here. I'm going to rewrite this as the integral of 1 all over, instead of 25x squared, I'm going to think about that as quantity 5x squared. I'm going to rewrite 9 as 3 squared dx. So now, basically in the place of x is a linear function 5x. So I can go ahead and move forward with using this arctangent formula, but in place of x, I'm going to have a 5x, and because that's linear, I'm going to remember that 1 over the slope has to also come out in front. So let's jump into it over here. Let's start to apply this formula. So 1 over a, 1 over 3 is going to be in front. Arctangent. Now, instead of x over a, what we have in place of x again is 5x. So we're going to have 5x over 3 plus c. But the biggest thing that we can't forget is because this wasn't just x, it was 5x, what's going to have to come out in front is going to be a 1 over 5, 1 over the slope. And so now we end up with 1 over 15 arctangent of 5x over 3 plus c. And now we have the integral of 1 all over the quantity 25x plus 9 dx. Now this is similar to the previous problem, except we have 25x instead of 25x squared. So we're not thinking about arctangent here. Instead, what we're thinking about is this sort of general antiderivative where if I have 1 over a linear function, so we know 1 over x gets us to natural log of the absolute value of x. But if instead I have 1 over some line, mx plus b dx, the antiderivative is 1 over the slope, so the slope is m, so 1 over m natural log of the absolute value of mx plus b plus c. So that's exactly what I have here, 1 over a linear function. So it's going to become natural log, but what has to go in front is 1 over the slope. 1 over 25 natural log of the absolute value of the line, 25x plus 9 plus c. And what's really happening here with pulling out that 1 over the slope is it's coming from the substitution method, or u-substitution, but we don't really want to have to apply a formal u-substitution if the inside, quote unquote, is linear. We want to just recognize how 1 over the slope is going to come out of applying that substitution method. And so in a later lesson, we will cover the substitution method a little bit more.